Hi, in this video we're going to talk about the first derivative test, which is a very important tool in calculus. And what it allows you to do, it allows you to see where a particular function is increasing or decreasing, and also where it may have a relative or local extrema, which is a relative or local minimum or maximum. So, what's the process that we follow? We're going to find the derivative of our function first. We're going to set the derivative equal to 0 and determine any values where the derivative is 0 or possibly undefined. Those are our critical points. We're going to plot the critical points on the number line and then determine the signs of f prime. And then we draw a conclusion about the behavior using the following guidelines. So if the derivative of the function is positive, then the function is increasing. If the derivative of the function is negative on an interval, then the function is decreasing on that interval. If you have some point C, which is a critical point, and the function is defined at that point, then if the derivative switches from negative to positive, going from left to right of that point, then the function is going to have relative minimum because it's going to switch from decreasing to increasing. And if the function is changing from, if the derivative is changing from being positive to being negative when you go from left to right of that point, then the function is going to have relative maximum. Also, please do not assume that a critical point must be a relative extrema. There must be a sign change of the first derivative for that to happen, possibly. Alright, let's begin with simple examples. So we have this function f of x, which is x squared minus 8x plus 6. So our process is going to start by finding the derivative. The derivative is going to be 2x minus 8, and then we're going to set it equal to 0, which is going to give us x equals 4. That's our critical point, so it's our critical value. Okay, so then we make a number line, put 4 here, and determine the signs of f prime. And on the bottom we're going to put the behavior of f. So f prime is going to be negative on this side, positive on this side, which means the function is decreasing here and increasing here. So as far as relative extrema, our derivative changes from negative to positive. So the function is changing from decreasing to increasing. We're going to have relative minimum at x equals 4. Okay. So the same kind of thing for this problem. So we're going to start by finding f prime, which is going to be negative 6x minus 18. We're going to set it equal to 0. That's going to give us x equals negative 3, and that's our critical point. I'm not going to identify them as critical points anymore. I'm actually not going to write it anymore. So we're going to make a number line, put our critical value here, put f prime of x here, put f of x here. So what's going to happen with the signs? It's going to be positive on this side, negative on this side, which means the function is increasing and then decreasing. So the derivative changes from positive to negative. That means that we have a relative maximum at x equals negative 3. Alright, moving on. F of x equals x cubed. Find all relative extrema and state where the function is increasing, decreasing. So we're going to start the same way. Find the derivative, which is going to be f prime of x equals 3x squared, set it equal to 0. And that's obviously going to give us x equals 0. That's our critical value. Now we're going to need our number line, 0. So we're going to put f prime of x here, f of x here. That's going to be positive and positive. So the function is increasing and increasing. If you think about the graph of x cubed, that does make sense. So what does that mean? In order for a function to have relative extrema, there must be a sign change in its derivative, but we do not have a sign change, so we have no relative extrema, no maximum relative extrema, no relative maximum or relative minimum, because the first derivative of the function does not change sign anywhere That's what I meant when I said a critical point is not necessarily going to be a relative extrema. What's going on with the function? The function is increasing where the derivative is going to be positive. So it's increasing here from negative infinity to 0, and also from 0 to infinity. You could also argue that you could go from negative infinity to infinity here, because there's really nothing important happens at 0, but that's actually not true, because it's a point that has a meaning, and that's going to be covered in later lessons. Okay, so it's just increasing on those two intervals. Find the relative extreme of this function instead, where it's increasing or decreasing. So we're gonna find f prime first, which is going to be x squared minus x minus 2. We set it equal to 0. That's an easy one to factor. It's x minus 2 times x plus 1 equals 0. And that's going to give us two values. That's going to give us x equals 2 and x equals negative 1. These are our critical points. And again, you cannot make any assumptions. You got to make a number line. And figure out the signs. So the signs here will be plus, minus, plus, which means the function is increasing, then decreasing, then increasing. So do we have any relative extreme? Well, at negative 1, the derivative changes from positive to negative. That means it's a relative max. At x equals negative 1. At 2, the derivative changes from negative to positive. That's a relative min. Now we also need to address the behavior. So where is the function increasing? It's going to increase wherever the first derivative is positive. So it's going to happen on the interval from negative infinity to negative 1. Negative infinity to negative 1. And it's also going to increase on the interval from 2 to infinity. And the function is going to be decreasing where the derivative is negative, so it's going to be between negative 1 and 2. Okay, so it's not a difficult thing to do. Right? Have one more example in this video. I'll find the relative extreme of this function. So it's given to us like that in factored form. One way, of course, to do it is expand all that, but that's going to be a nightmare. So we certainly don't want to go this route. So let's make our things a little bit easier. So let's do f prime of x. We're going to use a product rule along with chain rule. So we differentiate this part first. It's going to give us 3 times x minus 3 to the first power times x plus 1 cubed plus x minus 3 squared times, then we're going to have what? We're going to have 3 times x plus 1 squared. Of course, we're assuming that at this point you're familiar with all the differentiation rules, and doing something like that is not going to present any significant challenge. Okay, so here's what we need to do here. We're going to look for a greatest common factor. Let's see, we have x minus 3 here and x minus 3 squared. That means I can factor out, I'm sorry, that's going to be 2. Almost made that mistake. X minus 3 and x minus 3 squared, I can factor out x minus 3. I also have x plus 1 cubed and x plus 1 squared, so I can factor out x plus 1 squared. So inside the brackets I'm going to put what's going to be remaining. So I'm going to have these two. X minus 3 is gone, x plus 1, I'm going to have 1x plus 1 left, plus, here I'm going to be able to keep 3, x plus 1 squared is gone, it's going to leave us with x minus 3, because one of those x minus 3's is already been factored out. So you have 2, one's gone, one's left. So what we need to do is just simplify this part. So So let's see, we're going to have x minus 3 times x plus 1 squared times. This is going to give us 2x plus 2 plus 3x minus 9, and all that is going to result in x minus 3 times x plus 1 squared times 5x minus 7, and we're going to set it equal to 0. That is going to give us 3 critical points: 3, -1, and 7/5. So again, we don't know anything about what's going to happen until we make a number line and figure out all the signs. So let's see, we have -1 first, then we have 7/5, and then we have 3. This is f prime of x, this is f of x. So if you calculate the signs will be plus, plus, minus, and plus, which means the function is increasing, increasing, then decreasing, then increasing. So we need to figure out now where we have any relative extremum. So let's do that. So we have relative we have a relative maximum. Our derivative must change from plus to minus. It happens right here. Our first derivative changes from plus to minus. We have relative max at 7/5. And x equals 7/5. Do we have a relative min? Wherever the first derivative changes from negative to positive, right here, we have a relative min. Okay. What happens at -1? Nothing. It's not a minimum or maximum because the first derivative does not change the sign. Now increasing, decreasing. So the function will be increasing where its derivative positive. So where does that happen? It happens on -infinity to -1. It also happens on the interval from -1 to 7/5. And it also happens on an interval from 3 to infinity. Where is this function decreasing? Wherever the first derivative is negative. And that's going to happen on an interval from 7/5 to 3. Okay? And that's how it is. This is just a basic introduction to the first derivative test. There will be another video I'm going to be making for more advanced cases. Okay? And I hope this was helpful.